Welcome to This Explainer. Today, we are stepping into the role of the master strategist. Think of your Cambridge Physics 9702 exam like a high-stakes cricket match. You need to set your field, you absolutely have to read the bowler, who in this case is the examiner, and you need a systematic game plan to score your runs, which are those precious, precious marks. Today, we're diving deep into a topic that gets bowled at you in every single examination series: energy levels and line spectra, specifically focusing on emission and absorption. But we're not just going to recite textbook definitions. No, we are going to master the physics behind these phenomena strictly through the lens of the senior examiners. We are going to break down the core quantum concepts, look at exactly what the graders are hunting for, and build a foolproof strategy so you can stop leaving easy runs, easy marks, on the table. Let's get right into it.
Here's our game plan for today's session. First, the core principles. Second, mastering technical methodology. Third, the deconstruct, solve, evaluate loop. And finally, number 4, top examiner warnings. Let's move.
I want to start with a direct, incredibly revealing insight straight from the principal examiner reports. I want you to really let this quote sink in for a second. Candidates referencing cross-topic connections achieve significantly higher marks. Okay, what does that actually mean for you in the exam room? It tells us right away that mastering energy levels and line spectra is not just about memorizing isolated standalone facts. The examiner's throwing a spin ball, testing if you can see the bigger picture. It's about understanding how the quantum leaps of electrons between discrete energy states directly connect to the specific wavelengths of light we observe in a spectrum. Top-performing students, the ones securing those top-grade boundaries, they exhibit a connected, conceptual understanding that transfers seamlessly across the entire physics syllabus. They see the matrix, linking quantum mechanics to wave theory without missing a beat.
Now, this brings us to the ultimate question, the one that trips up so many students and instantly spikes exam anxiety the moment they turn the page. When you see a complex 5 or 6 mark calculation question sitting there on a emission spectrum, why is it so incredibly tough to secure all those multi-stage method marks? Well, let's look at 2 typical candidate approaches. Let's call our first student Alex. Alex knows a ton of physics, but in the exam, Alex completely overloads the answer with raw facts and equations, providing zero logical analysis or structure. Then we have Sam. Sam is panicking about the clock, rushing through the text, and completely missing the specific command word requirements. Both Alex and Sam are dropping massive amounts of marks, not because they don't know the physics, but because they don't know how to play the game. Before we continue and solve this exact problem, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, moving into Section 1, the core principles. The conceptual framework for energy levels relies heavily on precise definitions and establishing really clear causal relationships. And right here is where we see a massive red flag, straight from the examiners. They explicitly warn that candidates consistently confuse key terminology. Listen, if you are writing an extended response about absorption line spectra, you absolutely must explicitly define your terms before using them. You wouldn't step up to the crease without your pads on, right? Well, defining your terms is your armor. Prove to the examiner, beyond any doubt, that you know exactly what these words mean. For instance, clearly state that the ground state is the lowest possible energy state of an atom. Define excitation as the promotion of an electron to a higher energy level. You have to lay down these foundational definitions before you even attempt to build your analytical argument. If you skip this, the examiner immediately assumes you're just guessing.
And this table right here brilliantly illustrates exactly why that precision matters so much. Cambridge targets 3 distinct cognitive domains with these questions. You have to conquer all 3 to get full marks. First up is knowledge and understanding. This is your mastery of fundamental principles, knowing, for example, that an emission line corresponds directly to a specific photon energy released during an electron's transition downward. Got it? Okay. Second is application. This is where you prove you can transfer that concept to unfamiliar contexts, like calculating the exact wavelength of a specific transition using a given formula. And finally, analysis. This requires systematic, evidence-based reasoning. This is where you explain the why. Why are certain specific lines missing from an absorption spectrum? Think about a Peel framework here: point, evidence, explanation, link. If your foundational definitions from the knowledge stage are weak, your analysis is going to completely crumble. It's a house of cards.
Let's transition into Section 2, Mastering Technical Methodology.
All right, pay close attention because this brings us to the method mark strategy. In Cambridge physics exams, marks are heavily awarded for your systematic processing and procedure. Let me say that again. It is not just about the final numerical answer. The examiners are evaluating the specific logic of your journey, not just waiting for you at the destination. For example, let's say you're under pressure, the clock is ticking, and you accidentally drop a negative sign when calculating the change in energy levels, your delta E. It happens. But if your underlying analytical framework using Planck's constant was mathematically perfect and you clearly showed your steps, you are still going to pick up the vast majority of the points. You're still scoring runs even if you didn't hit a boundary. The process is everything.
Let's really hammer this home by comparing two totally different mindsets on game day. Remember our students from earlier? The amateur approach, what Alex and Sam often do, involves panicking. They see the question, grab a familiar equation like E equals hf, and just start plugging in random numbers without clearly identifying the initial and final energy states of the electron. It's a mess. The examiner can't follow it. The professional approach, however, the strategist's approach, relies on standardized sequences. It means pausing to clearly identify the specific energy levels first. It means executing your calculation with crystal clear working notation. It means correctly identifying and stating whether a photon is being absorbed or emitted based on the context. It is a highly systematic, repeatable process that forces the examiner to give you marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, welcome back. Let's move into Section 3, Deconstruct, Solve, Evaluate.
I am about to hand you your exact procedural framework for literally any high-value question on energy levels. You need to memorize this 4-step loop. Step 1. Deconstruct the question. Scan the text, extract the given data, highlight the command words, and pinpoint the exact context. Step 2. Select your analytical framework and break the problem down into logical, bite-sized steps. Don't try to do it all at once. Step 3. Solve systematically. Just like we talked about, clearly show you're working for the energy difference, delta E, and write out exactly how it equates to the photon's energy, hf. Use your notation like a pro. And finally, Step 4. This is the one that 90% of students completely forget to do. Evaluate. Check your final answer for reasonableness. Does the energy value you just calculated actually make sense for an electron transition in this specific real-world atom? If you get an answer that suggests the photon as the energy of a macroscopic baseball, you've messed up your powers of 10, right? Always justify your decisions.
Now, if you're sitting there thinking, how am I going to remember this structured 4-step approach when exam panic sets in? Try this memory hack. I want you to use a visual story method to encode these procedural concepts. Treat the complex multi-stage problem and the electron's transition itself exactly like a narrative you are actively unraveling. Picture it. The starting state of the story is an electron chilling in a lower energy level. Then, the inciting incident happens. The electron absorbs a photon of an exact specific frequency. Bam! The climax of our story is the electron leaping up to a higher unstable state. By framing the dry physics math as a dynamic sequential story, your brain will naturally, logically extract the right data in the right order and follow a highly systematic path. It's a total game changer for your time management matrix during the exam.
Let's tackle our final section, Section 4, Top Examiner Warnings. Listen up, because this is the absolute climax of our playbook. The principal examiner reports have combed through tens of thousands of candidate responses across the globe. And guess what? They have identified exactly 3 major repeating traps, 3 specific errors that consistently cost candidates their top grades in this exact topic, year after year.
You need to avoid these pitfalls like the plague. First, the classic trap, using the wrong approach for the context. If you use an emission framework for an absorption question, you're dead in the water. You have to tailor your formula to the specific atomic model or transition described in the prompt. Second, forgetting to check format and presentation. Remember our amateur Alex? If your working for calculating wavelength is an unreadable, scattered mess, the examiner literally cannot award you method marks. They aren't going to hunt for your correct numbers. Make it easy for them to give you the points. And third, providing generic answers. This is where Sam usually falls down. If the prompt specifically asks about a cool gas cloud absorbing light from a hot star, your answer must explicitly reference those exact environmental conditions. You need to explain how those specific conditions create dark absorption lines. Do not just regurgitate a memorized, generic definition of a spectrum from your textbook. Apply it to the context.
As we wrap up today's explainer, I want you to walk away with these ironclad takeaways. To truly master energy levels in line spectra, you have to push way beyond rote memorization. You need to forge those cross-topic connections to access the highest tier of marks. You need to build clear, standardized sequences when calculating, so your entire method is brilliantly visible to the examiner. And you absolutely must meticulously define your terminology before applying it to your reasoning. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
I'm going to leave you with this provocative thought to ponder as you dive back into your revision. If we know for an absolute fact that examiners are rigorously evaluating the specific logic of your journey rather than just waiting for a single correct number at the destination, how will you restructure the way you take your very next practice paper? Think about that. Put the deconstruct, solve, evaluate framework into action and watch those method marks soar. You're the captain now. Go set your field. Thanks for joining me on this explainer, and I'll see you in the next one.